Procuring an oxygen plant can be a complicated process. Build Health International is here to support you. We've compiled our expertise to prepare this video series to discuss some of the key considerations for oxygen plant procurement. In this video series, we'll discuss oxygen plant characteristics, infrastructure requirements, and planning for maintenance, including maintenance requirements, human resources, and spare parts. An overview of each of these topics will help you to prepare for oxygen plant procurement. In this video of the Intro to Oxygen Plant Procurement series, we will be discussing oxygen plant characteristics.
First, let us discuss PSA plant configurations. PSA plants can come in three forms: individual components, skid-mounted, and containerized. For individual component plants, the PSA plant equipment is shipped unattached and must be positioned and connected during installation. For skid-mounted plants, the PSA plant equipment is shipped mounted to several skids. A skid is a solid platform to which many different pieces of equipment can be mounted and then transported together as a single unit. The equipment mounted together on a single skid will come connected. The equipment is not moved off the skid for installation, and connections between skids happen during the installation. For containerized plants, the PSA plant ships assembled and connected inside of a shipping container to be placed on a prepared concrete pad at its final destination. Individual component plants and skid-mounted plants are placed in a plant house or room. Containerized plants are housed permanently in their container. In order to size a plant correctly, several factors must be considered, including number of patients served, types of patients, and likelihood of oxygen need. Number of patients served. A higher number of patients served may correspond to higher oxygen needs. Often, a hospital with 200 beds requires more oxygen than a hospital with 50 beds. However, this may not always be the case. That is because we must also consider the types of patients and their likelihood of oxygen need. Some types of patients will need higher flow rates of oxygen. For example, a patient in the operating theater will need oxygen at a higher flow rate than a patient in a general pediatric ward. Similarly, some services use oxygen more frequently than others. Patients in an ICU will likely require more oxygen than patients in the orthopedic ward. The number of beds, types of patients, and likelihood of oxygen use can be taken into account to size an oxygen plant. The best way to do this is to use an oxygen demand calculator. There are many publicly available oxygen demand calculators, and all use their own formulas to consider the three inputs for oxygen demand estimation. Some health systems will have their own criteria. This slide shows oxygen flow formulas from the United Kingdom's Health Technical Memorandum 02-01 for medical gas pipeline systems. Other calculators can be found developed by UNICEF, Open Critical Care, and PATH, to name a few. There is more than one acceptable answer and no precise method to size a PSA plant. For oxygen generated by a PSA plant, there are two main delivery methods: direct piping or cylinders. Direct piping. The direct piping method delivers oxygen directly from the PSA plant to patients at wall-mounted bedside outlets. When the PSA plant is on, oxygen is available on demand, like water at a faucet, as long as the total demand from the piping network does not exceed the capacity of the PSA plant. Cylinders. PSA plants fill oxygen cylinders at a high pressure to allow transportation of large volumes of oxygen. For example, the oxygen cylinders pictured on this slide each contain 7,500 liters of oxygen. Individual cylinders. Oxygen cylinders can be used individually, such as at patient bedsides or while patients are being transported. Individual cylinders are flexible and convenient, but proper safety protocols must always be followed to reduce the hazards of using pressurized oxygen in patient wards. Supply manifolds. Oxygen cylinders can deliver oxygen directly to patient bedsides by connecting to an oxygen pipeline. The arrangement of several oxygen cylinders to supply a pipeline is called a supply manifold. Booster compressors. Whether oxygen cylinders will be used individually or in a supply manifold, extra equipment will be needed in the PSA plant. Cylinder filling compressors, often called booster compressors, are the systems that fill cylinders at high pressure. Need both direct piping and cylinders? A PSA plant can be configured to provide oxygen using both delivery methods. For more information on the differences between oxygen delivery methods, see the resource document titled Comparison of Oxygen Delivery Methods, available at bhioxygen.org. PSA plants can be considered simplex or multiplex. A multiplex PSA plant uses multiple smaller PSA plants to satisfy the total oxygen demand. One production line is referred to as a simplex plant, 2 production lines is a duplex, and 3 production lines is a triplex. The lines of a multiplex plant may run independently or in parallel as one unit. Duplex plants are a popular option because they maximize the strengths and minimize the weaknesses of multiplex plants. The strengths of a multiplex system are redundancy, ease of maintenance, and efficiency. Redundancy. Multiplex plants provide redundancy, allowing for maintenance or repairs to occur in one PSA plant without stopping oxygen production. Ease of maintenance. Smaller PSA plant equipment can be easier to maintain as spare parts are easier to maneuver and lower volumes of substances like oil are required. Efficiency. With a multiplex plant, it is possible to turn off one of the production lines to reduce operating costs. Turning off one part of the plant reduces the power consumption and decreases the operating hours on the plant, allowing for less frequent maintenance. The weaknesses of a multiplex plant are the required footprint and spare parts. Footprint. With more production lines to accomplish the same oxygen production as a simplex plant, a multiplex plant will often require more space than a simplex plant with the same production capabilities. Spare parts. A multiplex plant will also have more spare parts to purchase and store. Checkpoint. What is a duplex PSA plant? Is it A, a PSA plant that is housed in 2 containers, B, a PSA plant that is housed in 2 separate rooms, C, a PSA plant that is made up of 3 or more identical plants that have a combined output that meets the total oxygen need, or D, a PSA plant made up of 2 identical plants that have a combined output that meets the total oxygen need? The correct answer is D. A PSA plant made up of 2 identical plants that have a combined output that meets the total oxygen need is a duplex plant. For more information on duplex PSA plants, see the resource document titled Briefing Note Duplex PSA Plant Configurations, available at bhioxygen.org. In conclusion, there are 4 key characteristics to consider when developing the specifications of a PSA plant. The characteristics of the PSA plant ordered should be customized to best suit the needs of the hospital. Consider the configuration. Should it be individual components, skid-mounted, or containerized? Consider the size. What the size of the PSA plant should be depends on the hospital. Consider the oxygen delivery method. Will oxygen be delivered via direct piping, cylinders, or a combination of both? And lastly, consider production lines. Would your hospital benefit from a simplex, duplex, or triplex plant most? Consider the strengths and weaknesses of each option.
We hope that you've enjoyed this introduction to oxygen plant characteristics. Continue on to learn more about infrastructure requirements for oxygen plants.